Hello everyone, welcome back to the Microservice Masterclass. So far in this series we have learned what microservices are, domain driven design, service boundaries, service granularity, stateless versus stateful service. Today we start another extremely important topic, API first design. Every microservice exposes APIs. Without APIs, microservices cannot communicate. Mobile application cannot access backend services. Front-end applications cannot retrieve data. Third-party integration became impossible. In other words, APIs are language of microservices. But here is the important question. Should we write code first and later design API? Or should we design API first and then write the code? Modern software companies like Amazon, Microsoft, Stripe, Google, and many other follow API first design. Let's understand why. Let's look at the first panel. API first simply means design the API before writing the implementation. Think about building a house. Do engineers start constructing walls immediately? No, right? First, an architect creates the blueprint. Everyone reviews it. The client approves it. Then construction begins. API design follows exactly the same principle. Instead of coding first, we first create the API specification. The API becomes an agreement between two teams. For example, imagine your company has front-end team, back-end team, mobile team, QA team. All four teams need the order API. Instead of waiting for the back-end development, the architects create the API contract. For example, post orders API, request response, validation, status code, authentication, everything is defined upfront. Now front-end developers can start building screens. QA can prepare test cases. Backend developer can implement the logic. Everybody works in parallel. What is API first versus code first? Look at the comparison table. API first gives us early feedback, better collaboration, clear contract, parallel development. Now compare it with the code first. Developers starts coding immediately. Later, documentation is generated. The problem, documentation often becomes outdated. Front-end waits for back-end, integration happens late, rework increases. This is why most enterprise companies adopt API first. Benefits as shown at the bottom of this panel: better API consistency, independent development, improved communication, easier testing and mocking, automatic documentation, auto documentation, faster time to market. Now let's see the API lifecycle. This shows the complete life cycle of an API. Think of it as a journey of an idea to production ready API. Steps 1: business requirement. Everything starts with a business problem. Customers should be able to place an order. This is one of the example. The second step is API design. Now the architect design the endpoint, which HTTP method, what request body, what response, what validations. Step 3: API review. The team reviews the design. The question includes: is the naming correct? Is it RESTful? Can it support future versions? Are error responses consistent? Step 4: Open API specification. Now the API is documented using OpenAPI YAML file. This document became the official contract. Step 5: Frontend and Backend development. Since the contract already exists, front-end developer and back-end developer work simultaneously. No waiting. Step 6: Testing. QA validates whether implementation matches the contract or not. Step 7: Deployment. API goes to the production. Step 8: Monitoring. Now we continuously monitor latency, errors, usage, performance, security. Remember, designing the API is only the beginning. The life cycle continues throughout the life of the product. Now let's move to the next section: REST API fundamentals. This panel explains the fundamentals of the REST API. Resources. In REST, everything is treated as a resource. For example, user is a resource, order is a resource, product is a resource, inventory is a resource. Notice, there are nouns, not verbs. Some good examples like users, orders, products. And what would be the bad example? Get users, create orders, delete product. REST focus on what the resource is, while the HTTP method describe what action to perform. HTTP methods. Each method has a clear purpose. Get retrieves data. Post creates a new resource. Put replaces an existing resource. Patch updates only selected fields. Delete remove the resource. Choosing the correct method makes your API intuitive and easier to maintain. HTTP status code. Your API should also communicate the result correctly. 2x success. For example, 200 is OK or 201 is created. 4xx client error. For example, bad request or 404 not found. 5xx server error. For example, 500 internal server error. Returning the right status code help client react appropriately. Understanding the URI structure. Now look at the example URI in the diagram. Get API v1 orders 1 to 3 items question mark status equal to shipped. Now let's break it down. Slash API is a base path. Slash b1 is API version. Slash orders resource. Slash 123 specific order ID. Slash item sub resource belonging to that order. And the question mark status shift query parameters used for filtering. This structure keeps API readable and consistent. Now let's move to the designing good APIs. A good API is easy to understand without reading documentation. Resource name, use nouns, not verbs, like users, orders, products. Never use like get users, create orders. URI hierarchy. Resources often have parent-child relationship. For example, users 1 to 3 orders. Right? This clearly communicates that the order belongs to the user 1 to 3. query parameter. Use query parameter for optional behavior such as filtering, sorting, pagination. For example, For example, orders, status shipped, orders sort, created at, orders, page 1 and size 20, orders, fields, ID, name, email. Avoid creating separate endpoint for every variation. Query parameters make API flexible. Now let's move to the next section, API contract. The API contract is promise between producer and consumer. The API exposes the API, consumer uses it. Both agrees on endpoints, method, request structure, response structure, headers, error format. Once this contract is approved, both teams can work independently. If the contract changes, it must be versioned and communicated. Section 6, OpenAPI Swagger. OpenAPI is the OpenAPI is the industry standard for describing REST APIs. It uses YAML or JSON to define endpoints, parameters, schemas, authentication, responses. With Swagger UI, developers get interactive documentation where they can explore and even test APIs directly from the browser. Benefits include always up to date documentation, client SDK generation, server stub generation, mock APIs for front-end development. Section 7, request and response design. A professional API should return consistent response. Create user, endpoint API v1 user, name, email and phone given. Now what would be the response? Success true, data, ID, name and message, user created successfully. Maybe timestamp. What should be the error response? Success false, error code validation error, message, email is required. Maybe it can have some details. Field, email, issue, email cannot be empty, timestamp. Notice that the structure remains consistent, making it easier for front-end application to parse responses. Next section is a standard response format. Instead of returning different response format for every endpoint, define one standard structure. Typical fields include success, data, message, error code, timestamp, and path. Consistency improves readability, simplifies error handling, and reduces client-side complexity. Let's summarize the today's lesson. A well-defined API should be designed before implementation, serves as a contract between services, follow REST principles, use meaningful resource names, return proper HTTP status codes, have consistent request and response format, be documented with OpenAPI Swagger, enable independent development across teams. The biggest lesson from today is code can change many times, but the poorly designed API can impact every client that depends on it. That's why great structured teams invest in designing API before writing the code. In the next episode, we'll move beyond API fundamentals and learn how to build production ready APIs. We will cover input validation, error handling, idempotency, API security, API versioning, real world best practices used in enterprise system. By end of that lesson, you will know how to design API that are not only functional but also secure, reliable and ready for production. If you found this video helpful, please like, share and subscribe to the Microservice Masterclass. I'll see you in the next episode. Till then, take care. Bye bye. Thank you so much.